Good morning, everyone. We are going to go over today's lesson, which is on exponent rules. So we're going to review, there are 5 different exponent rules that we're going to go over, and we'll start with some kind of basics, and then we're going to get into some more difficult ones. So feel free along the line if you need to pause or rewind and go back and forth between here and the daily log. You're not going to have homework today. So what you probably should start with is go on your daily log and answer the first couple of questions on there before we get to the practice problems. And then when we get to the practice problems, ready for that, you can start this. And if you want to do kind of section by section as I go through them, you can pause, go back and forth just to try to see how you are doing. So let's start with the first rule of exponents. All right, the first one is the 0 rule. And I won't bore you with why this is, but if you remember, the rule of any exponent or any base taken to the power of 0 is always 1. So any power of 0 equals 1. And again, I can bore you with this at another place and time. But for example, when you are solving problems, so let's say we have something like x to the 0 power. If you see that, x to the 0 power is always just the number 1. You can even try in your calculator if you want to. You can take any power if you do the caret and do 4 to the 0 power or 250 to the 0 power, you're always going to get the number 1. So even if you see something like 3 to the 0 power, that is always going to be 1. If you see something, I'm just going to do a bunch of examples for you so you can write down what you want, take notes, feel free to pause. If you see something like this, something in parentheses, so let's say that it says 2x to the 0 power, the whole thing is still 0. But be careful, if it was 2x to the 0 power, it would be 2, because this here, the x to the 0 power, that one is a 1, but not the 2 because of the parentheses in this one. There's no parentheses here, so that 2 is not being taken to the 0 power. So just be careful of that. They try to trick you with that sometimes. Okay, I think those are all the examples of a 0 power rule. So big takeaway here is it equals 1. All right, let's go to the second rule. So our second rule for powers is the negative exponent. Okay, so negative exponents are not happy and they're in the wrong spot. So whenever you see a negative exponent, in order for it to be simplified, it has to become back positive. And so in order to turn a negative exponent back to a positive is you have to flip the position on the fraction. So you have to flip it. If it's in the denominator, it needs to go to the numerator. If it's in the numerator, it needs to go to the denominator. So flip the fraction position. Okay, so we'll do plenty of examples for you so you can see what I'm talking about. So first example is, let's say you just have a good old x to the negative 1. So if you have x to the negative 1, it is not happy and it's not simplified. And so in order for it to be happy, it needs to go, it's on the top of the fraction now, we need to move it to the bottom. So you would write it as 1 over x. You can write to the first power if you want to, you don't have to, but it's just 1 over x now. If it was x to the negative second power, again, it would go to the bottom, it would change to a positive, and then also stay at the bottom because now it's happy. Even if you have a whole number, so let's say that you had 3 to the negative second power. The 3 is not happy, the 3 needs to go to the bottom. So we would flip it over to 3 squared, but we can do 3 squared in our head, so we're going to go ahead and write that as 1/9. So if there's any exponent that you can do in your head like that, I would just do it on your calculator. But if it was something like 7 to the 7th power, you can't do that in your calculator. It's way too big, so you can leave that. But if it's something that you can find in your calculator, go ahead and simplify it even more. Now, let's say that you had a negative on the top and the bottom. So let's say, for example, you had, let's do x to the negative 2, and then we had 3 to the negative 2 on the bottom. So neither one of them are happy, they're in the wrong spots. So we actually want to move the x needs to come down here, and the 3 needs to come to the top. Remember, when we switch them, we're going to switch places, and we're also going to make the exponent happy. So x squared will be at the bottom and 3 squared will be at the top. Or in other words, we can write a 9 here. So 9 over x squared. So if you've ever seen anything like that, you're literally just flipping the fraction and making the reciprocal. We'll go over some more examples of how we'll tie in these negatives in a minute. All right, let's go to rule number 3. All right, rule number 3 is the multiplication. Okay, so when you multiply exponents, and I bet you remember this. Okay, when you multiply exponents, the rule is you're actually going to add them, and I will explain why. So let's look at our first example of x to the third times x to the fifth. And so if you go back and you think about what exponents really are, exponents means that's how many you have of that particular type of number. So this means that we actually have 3 x's right here. And then x to the fifth means that we have 5 x's. And if you total them all together, there's a total of 8 x's. And so our answer is going to be x to the 8th. So if that's an easy way for you to do that and to figure that out, that's how and why we actually add when it tells us to multiply exponents, is you're finding the total number of exponents. Okay, let's go 0 to 100 and do a more difficult one right away. So let's try one with coefficients and different variables. So let's say we have 2xy to the 4th times 6xy to the 8th. Okay, this is just like terms. And so let's start with our whole numbers. Whole numbers are whole numbers, so we're not really going to add them. They're whole numbers, they're coefficients. We're going to multiply them like our normal number rules. So that's going to be a 12. And then the x's, we're going to put those together. So this x, I have 1 x here and I have 1 x here for a total of 2 x's, because there's actually an imaginary exponent right there on each of them. So it'll be 12x squared. And now the y's, I have 4 y's here and 8 y's here for a total of 12 y's. And so that would be my final answer. So multiply the whole numbers and then just add the coefficients or add the exponents in like terms. And that's about as difficult as it gets. If you see this as well, just to show you if you have a whole number base, so let's say it was 3 squared times 3 to the 8th, the base is just like your x. So this 3 here, you're going to keep that consistent and just keep that as a 3, and then add your exponents together. So you'll have 3 to the 10th. I wouldn't expect you to put that out. I don't think your calculator can handle that. So we'll just leave it as 3 to the 10th. But just so you see that you're leaving the base like it's the exponent or like it's the variable. All right, let's move on to our fourth rule, which is dividing. Okay, rule number 4 is dividing exponents. So do you remember, what do you do when you divide exponents? I know all of you are shouting, I know. You are actually subtracting. Okay, so the rule here is that we are going to subtract. All right, now our subtraction is very similar to what I showed you with the multiplication. So let's take a basic one first. So if I have x to the 6th over x squared. So remember what the exponents mean is that's the number of items that you have. So the top means that I have 6 x's, and the bottom means that I only have 2 x's. And so remember, in division, if there's one on the top, one on the bottom, they're going to cancel. So I could cancel that pair and that pair, and that leaves me with 4 x's, which is the same thing as doing 6 minus 2. But just wanted to show you why that is the case. So division means subtraction. Okay, let's take a look. Well, what happens if it was reversed? So what if you had x squared over x to the 6th? Well, now if we did this 1, 2, 3, 4, 5, 6, and 1, 2, whoop, wrong way, back that thing up. I have the 6 on the bottom now. Okay, so I have 2 on the top and I have 6 on the bottom. So now when I cancel, I have nothing left at the top, but there's always something. You can't have 0 left on the top if this is a simplifying problem. So there's still a 1, an imaginary 1 left on the top, and then there's 4 x's that are staying at the bottom. Okay, now if you were to have done this in your head, you would have gone 2 minus 6 and gotten -4, x to the -4th. And then you would have been like, wait, it's not happy. I have to make it happy. So I need to move it to the bottom. So you can think about it either way. You can think about it up here and like, oh, I know that there's more x's at the bottom. So x to the 4th has to stay at the bottom. Or you can say, I know 2 minus 6 is -4, but that's not right. I need to make it happy, move it to the bottom. So just be aware of that. All right, let's try one more where we do a little more complicated, where I have a coefficient and multiple variables. So let's try 8 x to the 9th times y over 4 x to the 5th y to the 5th. All right, so if we start with the whole numbers here, whole numbers are whole numbers, so we're not subtracting them, we are dividing them. So 8 divided by 4 is going to give me a 2, and that's going to stay at the top because the 8 is bigger. That's how I think of it. The 8 is bigger, so it's going to stay at the top. Next, I do my x's. So my x's, I'm going to subtract. Remember, it's division. So 9 minus 5 gives me 4. And there's more at the top. There's 9 at the top. So x to the 4th is going to stay at the top. The last one on the y's, okay, again, when I do my subtraction, I can do my subtraction, or I can think about this, that there are more y's at the bottom. So if I take one away, the y is going to stay at the bottom, just like the example that I just did right here. So it'll be y to the 4th at the bottom. Or if you subtract it, you would get y to the -4th, which puts it back at the bottom. And there's your answer. All right, our last one, last but not least, is going to be our power to a power, or exponent to an exponent. Okay, and the rule here, power to a power, is you're going to multiply. All right, so for this one, let's start with a more basic example. So we'll try x to the 3rd to the 4th power. Okay, so what this means, again, I'll show you real quick. X to the 3rd to the 4th really means that you are taking x to the 3rd 4 times. 1, 2, 3, 4. That's what x to the 3rd to the 4th power actually means. And so now if we look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 12 exponents here. So that's why we are multiplying, because you were taking a power to a power this time. So you're doubling the game almost here. Okay, let's try a different one. Let's try a little more difficult. Let's try 3x squared y to the 5th to the 2nd power. All right, if you see something like this and there's more than one, we are going to distribute. So you're going to distribute the square into each of these. So this is actually going to be 3 to the 2nd power, which is 9. And then x squared to the 2nd power would be x to the 4th. I'm multiplying there, not adding. And then y to the 5th to the 2nd power would be y to the 10th. Again, I'm multiplying. And that's it. Okay, last but not least, I'm going to show you some more difficult problems like multi-step. I'm going to show you 3 multi-step problems. Now this is going 0 to 100 real quick. And when I say that, it's because we are combining rules together into one. So let's take a look at the first one. This one is a little more easier than the rest of them, but let's take a look here. All right, so we got a lot of things going on here. And specifically, we have division happening, we have a fraction, we have a negative exponent, and we have a 0. So we have 3 rules happening all in one here. What I would suggest doing is start at the very first rule, which is that 0 means 1. So this y to the 0 power is really just going to cancel out and be a 1, or you can just get rid of it, excuse me, and not worry about it. Next, I would deal with the negative exponent. X to the -4 is not happy. So we're going to move x to the 4th to the bottom because it's not happy right now. So let's move it down there. and make it happy from x to the fourth. So now we have 1 at the top, and then x squared times x to the fourth, because we moved it down here. So now we have x squared times x to the fourth, which is x to the sixth. Whew. So 3 rules all wrapped into one. So again, I would go in order, take care of the 0, take care of the negative, then deal with any multiplication or division that may happen. Okay, let's try another more challenging problem, multi-step problem. Okay, this problem, we're gonna have 4x to the fourth over 6x to the seventh, all to the third power. So here we have division and we have a power rule. So that's really it right now. But my suggestion is, even though order of operations say to do exponents first, if you simplify the parentheses first, it will make your life way easier. I would suggest simplifying and then doing the exponent. That's just my suggestion. You can do it the other way, you'll get the same answer, but I would suggest simplifying. So I would first simplify this 4 over 6. So I would divide by 2 to the numerator and the denominator, and I would get 2/3. Then I would subtract these, and I would get x to the third at the bottom. Because again, remember, I have 7 at the bottom, 4 at the top, so they're going to stay at the bottom. Then I would take that whole thing to the third power, which is going to give me, when you take the fraction to the third power, every single thing in here needs to be taken to the third power. So at the top, 2 to the third power means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So you have 8 at the top. And at the bottom, 3 to the third power, 3 times 3 is 9, times 3 again is 27, or you can always do it in your calculator, x to the 9th. We can't simplify anymore. The 8 doesn't go into the 27, so our answer is right there. Okay, a lot to think about, but please pause and go back and listen to it if I'm going too fast. All right, last but not least, let's try one like this. So we have 3x times 2x to the negative third, y to the fourth, all to the negative second power. So we have 3 rules happening right now. We have a negative exponent, we have a power, and we have multiplication happening. So in this instance, my suggestion would be to first deal with the exponent. In this case, because it's not division, you'd want to deal with the exponent first. So I would first distribute this -2 into everything. Okay, so it has to go into everything. And remember, it's a power to a power, so you're going to be multiplying. So this will be 2 to the -2. Then that'll be x to the +6. But then the y will go to a -8 because I'm multiplying by -2. Now, what I would do next is I would deal with your negative exponents and I would change them to the bottom. You could, honestly, you could distribute this 3x in there right now, but the 2 to the -2 is kind of confusing to me, so I want to get rid of that. So the x to the 6 is going to stay at the top because that's positive, but 2 to the -2 is going to go down to the bottom as a 4, and y to the -8 is going to go down as y to the 8th, because remember, it's not happy, I need to move it to the bottom. Then I will multiply this by 3x lastly. Now, when I'm multiplying here, the only thing I can multiply is the numerator in here, because remember, it's 3x over 1. So when I do that, it'll be 3x to the 7th all over 4y to the 8th. I can't do any more division here. 3 over 4 can't be simplified, and the x's and the y are not the same variable, so it will just stay there. All right, go ahead and go back to your daily log, or if you haven't been going back and forth, and work on that and submit when you are done. All right, good luck. Let me know if you have questions.